In this video lecture, we'll learn about a few network performance parameters. The first parameter we are going to talk about is transmission rate. Transmission rate represents the amount of time it takes to get bits out of a sending node. So if we assume this as a sender node which wants to send data to this computer here, and let's say the sender has 10,000 bits of data it wants to send. It starts transmission at time 0. So it starts transmission at time 0 and then finishes transmission at time 10 seconds. So from the time it started, it took 10 seconds for it to finish the 10,000 bits of transmission. So the transmission rate at which the sender was transmitting is 1000 bits per second. This node was able to transmit 1000 bits per second. So that is the transmission rate from this sender to this receiver through this channel. So when we hear a Ethernet switch is a 10 megabits per second Ethernet switch, this is what we mean. The rate at which you are able to transmit data from sender to a receiver through a given switch is what is represented as the rate of that switch. So once we understand transmission rate, the next thing we are going to talk about is the throughput. The throughput of a network is represents the average amount of time it takes to have data sent between two nodes. So, but this is different from transmission rate. So let's talk about a similar example again. So here is a computer which is the sender, and here is a computer which is the receiver. They are communicating with each other through this switch. So if we assume the switch is a 10 megabits per second switch, if the sending node is sending data to the receiver on a continuous basis without any break, it will be sending 10 megabits per second from the sender to the receiver. So the throughput will actually become 10 megabits per second if you have that kind of continuous transmission from the sender to the receiver. But in reality, that doesn't happen for a variety of reasons. The sender sends data to receiver only for short periods of time. We will learn why that is in later lectures. But for now, if you assume that the sender is able to, so in a given time window, let's say this is 20 seconds of time which we are talking about. The sender is transmitting data for the first 1 second, and then let's say for the next 9 seconds it's not transmitting any data, and then let's say it transmits for 1 second, it's allowed to transmit for 1 second. So it's using the channel to transmit data only during 10% of the time. The throughput that is experienced in this scenario is actually 10% of 10 megabits per second, so which is only 1 megabits per second. So even though the throughput is related to the transmission rate, it is not necessarily equal to the transmission rate. It depends on how much the sender is actually transmitting. So this actually relates to the next parameter, which is utilization, which is what we just talked about. So if you have again the example of a sender trying to send to a receiver, and this is the channel resource that is being used for information to go from the sender to receiver. But for a variety of reasons, if the channel is being utilized only during the first, let's say, 2 seconds in this example, the first 2 seconds the sender is transmitting, and then for 8 seconds it's not doing anything, and then again 2 seconds it's transmitting, and for 8 seconds it's not doing anything. The utilization actually is only 20% in this example. And obviously you could make up different scenarios. You could have the sender transmitting for the first 1 second and then not for the next, the first 1 second and not for the next 4 seconds, and then it might transmit for 3 seconds, and then it may not transmit for another 5 seconds. And in this particular scenario, if you tried calculating the utilization, there's basically 1 plus 4 plus 3 plus 5, which is 13. So there are 13 units of time, and out of the 13 units, only 4 of them are actual transmission, and the remaining 9 of them are idling. So the utilization is only 4 over 13 times 100. So you get a percentage based on what portion of the time there is actual data transmission happening, and over the entire portion of the time which you are taking into consideration. And this is utilization of a given resource. And the final parameter which we want to understand is delay. And delay represents the time it takes for data to leave a sender and arrive at the receiver. So once again, if we consider the simple example of this particular computer trying to transmit to a computer that's directly connected through the switch, that delay represents the time. Let's say the bit leaves the sender here at 10 a.m. and it arrives, the first bit that left the sender arrives here at 2 seconds past that time. Then the delay is a 2-second delay for the bit to leave the sender and arrive at the receiver. In this same scenario, you could consider the sender and the receivers as being in different networks. So if this is the sender and this is the receiver, and the data is going to travel through this route and come this way before it arrives here, now delay became a little bit more complicated. You have the bit leaving here, again the first bit leaving here at, let's say, 10 a.m. and then how much time does it take for it to travel through the network and arrive here, and maybe it takes 5 seconds for it to arrive at this destination. Now the delay experienced by this sender-receiver pair is higher. So between transmission rate, throughput, utilization and delay, we have the main parameters that are needed for us to be able to talk about a performance of a network using quantitative measures.